All right, here are your solutions to assignment number 3. So let R be the region bounded by, and by the way, it's a calculator one, bounded by these graphs, and they're asked to find the area. I'm going to let you draw in here, and we'll do the calculator part together. Area is an integration question. I won't know my limits or top subtract bottom until I use my calculator. So that's what I'm going to do. So I'm going to graph this. I happen to have something there, so I'm going to go menu actions. I'm going to delete it, and we'll just go one at a time. So the first thing we're going to do is we're going to graph x cubed and then 1 plus x squared. I'm going to set my menu. I don't know what the window is, so I'm going to change the window. I want so much. I'll let that be for now. Okay, so there that is. Then the second one is 4 minus 2x. It'll be a different color. And so I want to find that area right there. So the area I'm trying to find is this area right here. Red above and blue below. So I already know this much. So it's bounded by the y-axis and then these graphs. So I already know top is 4 minus 2x. Subtract the bottom, which is x cubed over 1 plus x squared. And I know it goes 0. Now what I don't know yet is I need to find the bounds. I need to know where they intersect to find from 0 to what number. So I'm going to go menu, I'm going to go analyze, and I'm going to go intersection, number 4. And then I want to find that intersection. So I'm going to move this using the cursor pad to the left, press down, and then to the right, and then I get 1.487. And then that's what I'm going to put in the calculator. Now I'm just going to use the graph to help me integrate from there to there. So menu, analyze, bound area, bounded. So that's number 8. The lower bound is 0. I'm just going to type in 0. And then the upper bound is 1.487. Type it in. Enter. And then the area, so don't get confused by the point of intersection. So move that point away. The area is 3.214. See that? 3.214. And there it is. The next question is find the volume of that region, which is nice because I already have the bounds, when revolving it about the x-axis. So let me again have like a bit of a graph here. So you have something on top and you have a curve here, and this is the region here that we found the area of. If we're revolving it about the x-axis, it's going to be from the top to the bottom. So it's the top, subtract 0. Let's do it here. So the same thing from 1.487. So we have a big radius, subtract a small radius. So pi r squared and pi r squared when revolving, it's a circle. So the big radius is the top, subtract the bottom. That's 4 minus 2x, take away 0. And then the little radius is the curve, subtract 0, which is x cubed over 1 plus x squared, and then we're going to solve that. All right, we're not going to do that off the graph, so we're going to type that in. Sure you don't have it here. So menu, calculus, integrate. Again, we're going from 0 to 1.487. Oh, we need a pi in front. All right, parentheses, 4 minus 2x squared, subtract parentheses, I need a fraction, x cubed over 1 plus x squared. That's squared. And then dx, and then that's it. I hope I typed it in right. I have the answer. It should be 31.8845. You don't have to round. All right, the region R is the base of a solid. Each cross section is a square, and then find it. So if that's true, we're going to go top, subtract bottom for the base of the square, and then square it. So in other words, we're going to go 0 to 1.487. The base of our square is top, subtract bottom, and the formula is you take the base and you square it. That's how you find the area of a square. So we've already done top, subtract bottom. That's this. And then I take that answer and I square it. No pi in front, it's not a circle. So just like that, top, subtract bottom, all of that's the area squared, and then type it in. So menu, calculus integrate from 0 to 1.487. So we have 4 subtract 2x subtract parentheses x cubed over 1 plus x squared. All of that is squared, and then dx. And if I did it right, it should be, 8.997. Perfect. So some calculator work right now. All right, let R be the region in the first quadrant. Y equals 1 over the square root of x. Find the area. So again, this is an integration question. I'm just going to integrate this. So if I'm just finding the area of the region, this is a curve, but this is all positive. Subtract 0. So that's the integration of it. Menu calculus, integrate from 4 to 9. Control divide, and then 1 over the square root of x dx. And I get 2. If the line x equals k divides the region into two regions of equal area, what is the value of k? So from 4 to some number k is going to divide it into two equal areas. So the whole area is 2, so half the area would be equal to 1, and then you would solve it. So this is going to be an equation. So you're going to go menu, algebra, solve, and then you're going to do the integration, menu, calculus, integrate. You don't have to use k, it's a popular letter. Use whatever you want, but I don't want you to use x and x, so it has to be a number other than x. Control divide, 1 over the square root of x dx equals, oops, try again, move the cursor, equals 1 comma x. So make it equal to 1, solve it. Oh, why didn't it solve? Oh, I know why I didn't. Silly. I said comma x. I'm not solving for x, I'm solving for k. Control enter. It's 2.25. Oh, what mistake did I make? It's not 1 to k, but 4 to k. So the bottom limit should have been 4, not 1. focused. So that should have been 4 to k, so that k value would be 6.25. That was split in half. Find the volume of the solid whose base in the region R and whose cross section is cut by planes perpendicular to R squares again. So again, area is base squared, and base is top subtract bottom. Now for us, 1 over the square root of x is the top, and the bottom is 0. So in other words, when I take it from 4 to 9, I'm just going 1 over the square, and I'm squaring it. And this would give me the volume using a square. I'm going to save you time. Put that in the calculator. That's 0.811. Make sure I did it right. Next question. Let the region enclosed by this graph and the vertical line x equals 10 and the x-axis. It says find the area. Area is an integration question. From the x-axis to 10, if you need a little sketch of it, it's actually not going to be 0, right? It's going to be, because 0 is the square root of -1. It's actually going to be positive 1 is where it starts, right here. So from the graph, this is going to be 1 because 0 gives you the square root of -1. That's fast. So it starts at 1, and then it goes to 10. If you plug in 10, you get the answer 3. 10 take away 1 is 9, and the square root of 9 is 3, and it's some curve here, right? And so we want to find this area. That's kind of what it looks like. Okay, so 1 to 10. Type that in your calculator, and you get 18. Find the volume of a solid generated when it's revolved around the horizontal line y equals 3. So here's y equals 3. And so I'm going to do b right here. Again, it's integration from 1 to 10. So revolving means a circle, and we have 2 radii, a big one and a small one, because there's a space there. So from here, the big radius is 3, take away 0. And the little radius is 3, take away the curve, which is the square root of x minus 1. That's what you would type in. And if you type that in correctly, you get 212. You should practice. 212.057 or 8 if you want to round. Part C. The solid is generated. Again, revolved means a circle. Now it's a vertical line. X equals 10. So now we're going sideways around 10. Now we have to switch it around. So because it's a vertical line, everything needs to be in terms of y. So it's still pi, but the y values. What's the low of that y to the upper? That's 0 to 3. And then we're going sideways. So if I go right, subtract left as I'm revolving around it, there actually is only one circle. So from right, subtract left, there's no gap. So it's going to be that vertical line 10, subtract, this is the radius. So 10 subtract the curve, which is the square root of. Now we have to change that. So wait. So it is y equals the square root of x minus 1. We have to square it, and then I need to add 1. So x is equal to y squared plus 1. So this is going to be y squared plus 1 with parentheses around it, and that's going to be squared. So that's the radius there. Right, subtract left in terms of y. And if you did that right, it'd be 407.150. So try that on your calculator. All right, let f be the function, this one, and let L be this line, where L is the tangent line of the graph of f. let R be the region bounded, and it's graphed here by the x-axis in the graph of f, and let S be the region bounded by the graph of f, the line L, and the x-axis is shown below. Show that the line L is tangent to the graph at x equals 3. So x is 3. The y coordinate, if I plug 3 in here, that's 3 squared, 9, 4 times 9, take away 27. So 36 take away 27 was 9, right? And then the slope, I need to do the derivative. That's 8x minus 3x squared. And then plug in 3, and it'd be 24. Take away 27, that's negative 3. So if I put this together, you would have negative 3, x minus 3 plus 9. That gives me exactly that. So negative 3x plus 18, and you've shown that that is true. Order doesn't matter. B, find the area of region S. So to find this region right here, so we're going to go top, subtract bottom, I need to know this value right there. So we are going to, if you take 18, take away 3x, and make it equal to 0, what is that point? So if I add 3x and divide, that number, this number here is 6. I need to know that number too. Oh no, we'll just do it from here, from this number. We know that number is 3. So it's from 3 to 6. And then we have this one. So that number I actually do need. So that's region R. That is, and you can use your calculator, 4x squared minus x cubed equals 0, and find that value. So you would go menu, control, menu, algebra, solve, and then you would solve it 4x squared subtract x cubed equals 0, comma x. You get 0 and 4. So I don't need the 0, I need the 4. So the first is going to go from 3 to 4. And top subtract bottom. So top is the line, which is 18 minus 3x. Subtract the bottom, which is the curve, which is 4x squared minus x cubed, plus, we'll just type this in the calculator in one step. The next part, so this is like part 1 and part 2. Again, we have a line, but the bottom is just going to be 0. So we have 18 minus 3x subtract 0, which we don't need. And again, that goes from 4 to 6. And then this is what you would type in. And if you did it right, you got 7.916. So try it. Part C says find the volume of the solid generated when R, not S, is revolved about the x-axis. We have R around here. So that's from 0 to 4. I'm going to do it right here. So from 0 to 4. Revolving means a circle. Notice there's no space here from the x-axis and the R. So it's just one solid circle, a disk. So 1 radius, top subtract bottom is just simply that curve subtract 0. So it's 4x squared minus x cubed. So there's the one circle to find the volume. And if you did it correctly in your calculator, it would be 490.208. Make sure 3 numbers after this. You do need to practice your calculator to do this. But if you did it, see if you get the same answer. All right, last one here, number 4. The shaded regions R1 and R2 is right there. Shown below is x squared and 2 to the x. So find the x and y coordinates of the, let me get it like this, of the points of intersection. So we're going to make these simply equal to each other, and then tell me what x equals. So let's go. That's menu algebra solve. X squared equals 2 to the x, comma x. And they said the points, right, of intersection. So the first point would have negative. We'll do that in a second. So negative, and we can use either equation for the y coordinate. So I'm just going to go negative 0.76, square it. So the y coordinate would be negative 0.588. Or just, sorry, positive 5 points because it's negative. It's a negative times a negative. So it's 0.588. So the first point is negative 0.6767 and 0.588 using your calculator. Next one, 2 and 2 squared. And then 4 and 4 squared would be 2 and 4 and 4 and 16. Without using absolute value, set up an expression, but don't evaluate in terms of the area here. So I'm going to do that here. So the first one goes from negative 0.676 to 2. That's like from here to here. The top is the exponential. Subtract the bottom, which is the parabola. Plus, then we're going to go from 2 to 4. Now the top is the parabola, subtract the bottom, which is the exponential. Alright, part C, last part. Set up an expression involving to give the volume of the solid generated when region 1 only, that's this part only, about the line y equals 5, somewhere up here is 5, wherever. And so if I'm revolving, it's a circle, and again negative 0.676 to 2, just region 1. So the big radius, the top is 5, subtract the bottom, which is 2 to the x, squared, minus, and then the little radius, the top, subtract here, which is the parabola. Right? Am I getting it mixed up here? Alright, top, the bottom, well, the bottom is the parabola. So from here to here, this bottom is the parabola. And then the little radius, 5, take away that part there, is the exponential. So there's the setup to find it, but don't evaluate it. All right, Mr. G Math over and out. Great job practicing and reviewing today. Until next time.